So let's talk about one other thing, which is half-life. So people are often very concerned with half-life. When do you hear about half-life a lot? Does anyone know? Yeah, we talk about radioactivity, which we'll be talking about next class. They're very concerned about the half-life, which is the time it takes for the full amount of your original material to be reduced by a half. So we can look at an equation that we had up above for our integrated first order half-life. And we can think about this in terms of a half-life expression. So here, T has a particular special meaning. We have T a half, which is the abbreviation for half-life. And so half-life, by definition, is the amount of time it takes for the original concentration to be reduced by half. So here we have our final concentration of A at a time t. So when we're talking about half-life, we're going to have half as much as we had when we started. So our AT is going to be our original divided by 2, half the amount we had in the beginning. And so now T has a special name. It's T to the 1/2 here. So now we can solve this, simplify this expression to come up with an expression for half-life for a first order reaction. So the A to the 0 or original concentrations cancel out, and so we have the natural log of a half equals minus K, our rate constant, times T 1/2. The natural log of a half is minus 0.6931. We can get rid of our negative signs and solve for T 1/2, because this is the half-life expression. So T 1/2 equals 0.6931 over K. So that's an expression just for a first order half-life. And notice that half-life does not depend on concentration here. That term dropped out. So half-life depends on our rate constant K, and K depends on the material in question. So for radioactive material, some radioactive materials have short half-lives, so their Ks are very different from each other, and so that can be very important, especially when you're thinking about storing radioactive waste. So using that value, tell me, for the same material then, does it take longer to go from 1 ton to a 1/2 ton, or from 1 gram to a 1/2 gram? Okay, let's just do 10 more seconds. Yep, takes the same amount of time. And then just to finish up here, we have one more thing to do, and then we're done. So here in a plot for a first order half-life, the concentration of the material at the first half-life has dropped by how much? A half. At the second half-life, it's what? And the third half-life? Yep. So that's first order half-life.